what we are going to cover in this particular session. Today's topic will be to understand core window functions in MySQL. We will compare what's the difference between a window function and group by. We will apply aggregates in window function, and finally we'll take a look at some ranking window functions as well. So today's discussion is focused on understanding window functions in MySQL. So without further ado, let's get started. So first, let's define and understand what exactly is a window function. So in order to understand a window function, let me take a simple example. The example is to calculate cumulative sum of salary in your employee table, right? So I have given an employee table to you. In that employee table, I ask you to calculate cumulative sum of salary across all the rows, right? So let's say you sort the employees in the ascending order of their employee ID. After sorting the employees in the ascending order of the employee ID, I ask you to calculate a cumulative sum across the salary column. I hope everybody knows what a cumulative sum is. For those who don't know, a cumulative sum simply means that if I am at row number 5, assuming that I want to calculate cumulative salary at row number 5, then that will include sum of salaries from row number 1 to row number 5. Same way, if I am at row number 10, the cumulative salary at row number 10 will be the sum of salaries from row number 1 till row number 10. So cumulative salary or cumulative sum simply means for any given row, it's the sum of all values starting from the first row till that particular row. So a cumulative sum till nth row equals sum of all values from row 1 till row n. Now, how would you implement such a function? Because here when we calculate sum, we know that when calculating sum, you are doing an aggregation. And we know whenever we do an aggregate, we have either gotten an option like just calling the aggregates function on a standalone basis or calling an aggregate function using group by. We have already seen both these two examples, right? So we can either aggregate using the standalone function wherein we calculate just sum, or we calculate a group by in which we pass a categorical column, and then based on each category we calculate the aggregate. Now both these two use cases will not meet our requirement, because what we want an aggregate at each row level, right? So I hope you're getting the point, right? So if your employee database has 1,000 employees, then you need an aggregate at each row, and the aggregate at each row will be including in this example the sum of values from first row till that row. So in other words, for each row you have a window defined. In this case, the window extends from the first row till nth row. So in example of calculating cumulative sum, our window starts from the first row of the table and extend up till the nth row of the table. And all the values which are part of that row will be included in aggregating the value for the current nth row. Right? So for the cumulative sum of nth row, we calculate sum from first row till nth row. Same way, for if you move to the next n plus 1th row, then that will include sum of values from first row till n plus 1th row. Right? So for each row, the aggregate changes and the window correspondingly also changes or moves. So therefore, there comes the use for a window function. So if you read the definition here, it will become clear now. A window function is used to do a calculation across a set of rows that are related to the current row. And the current row is the row for which the function evaluation occurs. I hope now the definition becomes clear. So here we are doing a calculation for each and every row in our entire employee database. So for each of the 1,000 rows, we are making a calculation for the cumulative sum, right? And for each cumulative sum, we are only including values that are related to the current row. So in this case, the relation is defined as starting from the first row till the current row. All right. So these relation is defined in respect to the current row that we are at. And the current row is the row for which the evaluation occurs, right? So the evaluation that you will do for the current row, it can or it cannot extend to the other rows as well. But here your point of focus remains just the current row. You don't care about the remaining rows. You do an aggregation specific to a current row. And the window dictates how many rows you will include for doing the calculation for the current row. Right? I hope this gives a brief picture of what's the use case for a window function. The syntax of a window function includes a lot of different things, and it's not necessary to use each and every part in each and every window function. I'll go step by step and I'll give an example wherein we'll take into consideration each and every part here that's mentioned so that it becomes more and more clear. So first, a brief syntax goes like this, in which you start off with the window function name. There are different types of window functions. Some window functions used for aggregations, others are used for ranking. We will understand both of them. So you write the name of the window function. Then whenever using a window function, you have to use this over clause. So after writing the window function name, you have to write the over clause. Inside the over clause, you write the column which is called partition by. We will take a look at what does partition by means. I'll give you examples of this as well. And you have then order by, which are a part of this window function. So in a window function, you write a window function name, and inside over clause, you write partitions and order statements. Right? So I'll give complete examples of each and every one of these subclauses in the coming slides. So just to give you a brief of what I have just covered. So a window function is similar to aggregate function combined with a group by clause, but has one key difference. Window function retains the total number of rows between the input table and the output table. So here, unlike group by, remember in group by what used to happen? Whenever we used to apply group by, let's say you want to calculate average salaries for each department. So the group by statement will return you the number of rows equal to number of departments. So if your department, if your company has 5 departments, then the group by statement will return 5 rows, one for each department. But in this example with window functions, that's not the case, because as I mentioned, in window functions, for each row the computation happens separately. So therefore, the input and output will remain same. The number of rows in the input table and the number of rows in the output table hence remains the same. Right? So behind the scenes, the window function is able to access more than just the current row of the query result. How it is able to do it? It is able to do it based on the window that we have defined. All right. So let me give a simple example first, with which you get an idea behind what exactly do we mean by window function and how does it compare with a group by statement. So let me go to MySQL Workbench now, and here let me practice these window functions. Let me give a title here, window functions. And here I'll just specify which database I want to use here. So I'll just use company DB. Now let me give an example of a simple group by statement, and then I'll explain how you can do the same thing using window functions, but the output and input sizes will remain the same. So here, let me run a simple operation here. Let me do select department number and average salary only, because that's the example that I have been giving. Let me rename it as average underscore salary. This I'll do from my employee table. Right? And here I want to do a group by department number. Let me just beautify it a little bit, because why not? Right. So here, let me run this query now. And you can see here in our employee table, we have 3 departments. Hence, the aggregation returned only 3 rows for us. Right. So now if you want to do something like what I had mentioned, in which you want, let's say now you just don't want this. What you want is, you want against each department, I want the average salary, but the number of rows in input and output should remain the same. So there you can basically use something called as a window function. How you can use a window function in this place is something like this. Let's say select department number and average of salary, right? And now will come the part for when you define the window inside the window function. Right now I'm calculating my average salary. So this is the window function that I have defined. Now I will define the, you can say I will define how I want to aggregate this average salary. So currently, if I don't do anything, right? So here, imagine I'm not specifying anything inside this over clause, right? And just let me call this as average underscore salary. And this I'll do from my employee table. That's it. So if I run this statement right now, so what you will find is that you can see currently we are calculating a single point estimate for average. So this includes average for all the rows that we have. So if you compare this with the single run of an average column, the results would look like this, right? So what I'll do is, if you just simply run this, that select average of salary from my employee table, you will see that in this average, this is what the average looks like. So without a group by statement or without the window function, we get a single point estimate, which is 35,125. Now, if I want this single point estimate to be mapped to each and every row of my employee table, simply what I have to do is basically just specify my over statement. So this over will do what? It will basically take this column and map it across each and every row of your original table. And it will ensure that the initial input and output size remains the same. So here you will now see that the number of rows are getting equal to the number of rows in the input. Without this over clause, we had what? The number of rows was single. That is, we only were getting a single point estimate. Right? So this is basically just a comparison between the aggregation clause without the over clause and an aggregation statement with an over clause. So if you run it with just an over clause and don't specify anything inside the over statement for now. So within this over, I'm not specifying anything. I'm just leaving it as it is. So then the change will come is that the number of aggregations will be mapped to each and every row of your table. So this is basically like, if you want to know in your employee table itself, want to create a new column which contains the average salaries of these employees as well, then you can do it simply by running this statement. Right? And you can run multiple statements like this. Let's say here I calculate one column as average underscore salary. I can also calculate another column. Let's name it as total salary. So sum of salary. Let me run it in new line. Over as sum of salary. And this I am selecting from my employee table. So here you will see that I am doing two aggregations. First aggregation is to calculate the average, and second aggregation is to calculate the sum. But this time what you will find is that now I will get two columns. In the first column I will have my average salary. In the second column I will have my total salary. And both of them are independent. So this window function is running independent of the second window function. Right? And since we have not specified anything inside the over clause, so it's basically treating all the rows for calculating aggregations for each and every row of your input table. Right? So window currently contains all the rows from your input table. So for each row, you want to include all the rows from the input table. We have not done anything customized right now for each and every row. So that is one example in which I'm comparing how a default aggregation simply like this, right? So you look simply like select average salary and sum of salary. So if you run it without the over statement, the output looks something like this, right? So here from employee table. Here I'm running the same aggregations, but this time I'm just running it without my over clause. And as I run this, you will see that without it, I will only have a single point estimate for both the aggregations. But with my over statement, I will be able to map it for each and every row of my input table. Right? Now I'll take this group by example again, because now this group by example will become a little bit more easier to understand. So let me just copy paste this group by example down below. Now let's understand what happens with group by. Now earlier on we were doing without any group by, but here if we do it with a group by, then what will happen is that we will have the aggregate for each department in our employee table. So for department 1 average salary, department 4 average salary, and department 5 average salary. Now what if you want these values to be mapped to the original table as well? That is, against each department you want these average salaries to be present. Right now what you have a choice is that now you can join it with the original table and get it done. Right? So after you have calculated it, right, so you can do something like this, that once you have calculated this statement here, you can convert it into a common table expression. Right? So with, let's call this department average as this one. Right? And now you can see, so we have created a temporary table called department average. Now I can take my employee table, select star from my employee table, and do an inner join with my department average table on employee.d number equals department average dot d number. So here this query will do the exact thing. That is what it will do is that it will take each row from the department column here against each department, whatever is the average. It will take that average and create a new column in my employee table for that average. So if I now execute this query over here, so you can see towards the end we have a column created called average salary, in which against the department we have the average salary for that respective department. So you can see for department 1 this is the average, and for department 4 these are the averages. So as long as the department number remains the same, the average for that department will obviously remain the same. But current execution requires a lot of programming efforts, right? So here you can see you have to create something like a nested query and then use a nested query to create, that call the outer query, which is a very tedious task. What if I tell you you can do the same thing with a window function as well? So how will we do it with a window function? So here you can see instead of selecting all the columns, I'm just selecting a couple of columns here. So let me select employee ID, department number, salary, and average salary. Now this time inside the over statement, I will specify a partition. So this is where the use for partition comes into picture. Right? So now I have to define my partition. So how will I define this partition? So the partition is defined using the clause partition by. And after partition by, I'll specify how do I want to partition my data. What it will do is that it will work similar to group by, but this time instead of returning you a single result for each data for each department, it will take that value for the department and map it across the original table. So here if you see, what will happen is that after partition by, I have specified which column do I want to partition the data based on. So imagine we have three departments, department 1, department 5, and department 4. So here it will create three separate sub data sets or subsets of data. One subset will contain department 1 subset will contain department 5, and one subset will contain department 4. Then it will calculate aggregations only for rows in department 1, take that aggregation and map it across row for department 1. It will take aggregations for department 4, map that aggregations against row for department 4. And it will calculate an aggregation for department 5 and map it against the rows for department 5. So if I run the second query now, what you will find is that, one second. This time if you see, we have the same result but with so much less effort. So here you can see against department 4, we have only the average for department 4. Against department 5, we have the average for salaries in department 5. So you can calculate the average of these highlighted values. That average will come out to be 33,250. You can calculate the average for these highlighted cells. Since they belong to same department 4, the average will come out to be 31,000, and that is same copied across all the rows. In same way, since we have only one row in department 1, so that's why we are getting the same value as average salary. But I hope you get the idea here. So this window function is basically applying an aggregate for each department in our department table and taking that aggregate and mapping it back to your original table. So similar to how the previous query worked. So you remember this query? This query was also giving us the same result, but here the programming effort was significantly more. So here we had to first calculate inner table and then join that inner table with an outer table. But the results are pretty much the same. So for department 5, the average was 33,250. For department 4, the average is 31,000, and for department 1, the average is 55,000. So the rows are exactly the same. It's just that doing it with window function requires much less efforts. Alright, so I hope this has given you an introduction to that. And as I mentioned, you can just keep on appending more and more columns. So if you want, you can also calculate sum of salary over. You can define different partitions as well. Let's say this time you want to define, when you calculate the sum salary, the second partition that you want to define is based on gender. So you can change the partitions as well, right? So here let's say sum of salary, but the sum of salary is being calculated for each gender. This time what will happen is that it will aggregate data for male, it will aggregate data for females. The aggregate for males will be mapped to only for male rows, and the aggregate for females will be mapped only to your female rows. If I run this query now, so what will happen is that you can see we have two columns. The first column is the average salary. So here let me include the gender column as well so that I can demonstrate that as well. So 6 also I'll include. I'll run this query now. So now for each department, so let me run the query for each department. So you can see for department 1, average salary is 55,000. For department 4, all the average salaries are 31,000. And for department 5, all the average salaries are 33,250. Now let's look at gender. So for all females, total salary is same, which is 93,000. And for all males, total salary is same, which is 1,88,000. Alright. So whatever partition you will define inside this, that partition will be used to aggregate the respective window function that you have specified. Hope this gives you a clear idea about what window functions are and how to run simple window function queries in MySQL. Let me go back to the presentation now. So here you can see, when would you notice that window functions are being used? So this is a very common question that people are often faced with, like when do you calculate or use a window function in a day-to-day life? So whenever you want to calculate something called as running averages or moving averages or running totals, cumulative sums, ranks, percentiles, etc., that's where the window function comes into picture. Right? Say I give you a stock price data, right? So in this example here, I'll give you a simple stock price data, and in that stock price, I'll ask you to calculate this past 7-day moving average. So in that case, you can simply specify a window function that can calculate for current row. It will take into consideration last 7 rows with respect to current row and use only those many rows to aggregate the average for current row. Right? So that is what a running average or a moving average would look like. Same way you can calculate running sums. So whenever you want to calculate a dynamic aggregation across each and every row of your data, that's where the window function shines. And second use case would be that when you want to map an aggregated data to the original data set. So after calculating the group by, you want that row to be mapped back to the original data frame. So instead of doing a join, simply run a window function using partition by clause, and it will create your new column in the same data frame or the data set which you have run the query on. We will take a look at ranks later on, but for now I have just given you an example of how to calculate an overall sum. So here the examples which I have shown you That is not an example for a cumulative sum or an aggregate or running aggregate. Running aggregates and all I'll come to in a second. But the example which I have shown basically is an example in which you include all the rows to calculate an aggregate for a current row. It's a much simple implementation for that. But these are the usual use cases wherein window functions are used. Alright, so just to brief, you want to use a window function when you want to measure trend or changes over rows or records in your data. Right? So when you want to measure the trend or the patterns that are coming in your data, or you want to rank a column such that you want to prioritize a few values and deprioritize the other values. So using window functions, you can even calculate ranks for each and every row of your data. I'll show you that also in a coming slide. So these are the most common use cases for window functions. Either you want to measure the trend or the patterns in your data for each and every row, or you want to assign a rank to each and every row of your data. Here is a link in which you can go and read more about window functions usage. Right, so practical usages are there in this HTML. We'll talk about the implementation right now, but this is just for reference purposes for anybody who is interested. I'll share this later on. Now, we'll take a look at some core window functions today. Right, and as I mentioned, they are effective when you want to measure trends over time or rank a particular column, and it retains the total number of records without collapsing or condensing any of the original data set. So that's the main highlight of a window function. So it allows you to calculate an aggregate for each row without collapsing the number of rows. All right, so that's the main highlight. And why they are so powerful is basically the readability advantage. So I've already shown you that if you did not want to use a window function and you want to map that group by data group by table back to your original table, you would have to run multiple queries to simply map those rows back. The readability is not that good. If somebody is not well versed in MySQL terminology, it might be a little difficult for him to make sense of that query. Compare it to the query that we ran in window function. It was single liner. It did not have anything complicated there. It was just a single line of code, like you make selection for any given column. Similarly, here also we just wrote a single query, and using that query, we were able to achieve the task that we had presented just prior to that. Right, and the performance also is much better. Right, so in this case, the way window functions operates, they are a little bit more efficient as compared to a group by and a join run together. So now let's talk about partition by and over in more detail. So when you use partition by, I've already given you an example of partition by. Here I just want to formalize how you use it. So consider partition by like a group by only, in which you specify which column you want to aggregate the data on. So just like in group by we specify the categorical column which will be used to aggregate the data, here also inside partition by you specify which categorical column you want to aggregate the data on. In our examples, we have specified in one column I use the column gender. In other example, I use department. In some other example, you can specify whichever other column you want, and you can even specify more than one columns also. So if the requirement is that you want to calculate gender-wise department averages, then you can even do that. All you need to do are specify comma separate values there. So partition by column 1, comma column 2, and that will allow you to partition by 2 consecutive columns. And these partition by clauses are written inside the over clause. Right? So immediately after the window function, you write the over clause. Inside the over clause, you write the partition by and the columns with which you want to create those partitions. All right. So I'll again show you the examples, just that we are on the same page. I'll again go back to the MySQL workbench and I'll just revisit the examples that I had written. So if you remember these examples, I just want to highlight the contrast between how you would have done it without a window function and how we did it with the window function. So remember this first statement which I had written, in which I was doing an aggregation for calculating average salary and total salary here from my employee table. So right now these aggregations will return me a single row. But if I want to take these aggregations and map it for each and every row of my table, in that case, I have to run a window function like this. So in this window functions, you can see that in the previous query also there was no group by written anywhere, meaning that consider all rows as one and do a point estimate for all the rows without doing any group by. Here also this logic is same because we have not specified any partition by clause. So what it will do, it will calculate an average for all the rows from your employee table without creating any partitions. Same way for sum as well, it will calculate sum across all the rows from your employee table without creating any partitions. This was the first example. In the second example, we wanted to calculate a department-wise average, but we wanted to map those averages back to your original table with the help of the department column. So here you can see I first defined an inner table or a common table expression. We have already talked about common table expressions in our previous classes. For anyone who is not aware about a common table expression, just visit the lecture prior to the previous one. In that lecture, we have talked in detail about what a common table expression is, and we have given a couple of examples for those as well. Here you can see I have defined this table called department average. This is a temporary table. In this temporary table, I'm creating it by calculating my department number and the average salary for that department. And this group by is done by department number. So here you can see I have specified a group by column. And then once this table is created, I take this table and I join with my employee table. This join is done using an inner join, and this is using this temporary table which I have created above. Once the temporary table is created like this, you can use it just like a normal table as if it was present in your database only. That's why you will not find any change in the syntax which I'm writing here. And I specify what columns I'm joining it on. So both the tables have the department number column, so therefore I can join these two tables using that column. So when executing this query, you will find that here we have instead of having a single average which includes all the salaries from this employee table, we have averages specific to each department. The first 4 rows contains average for department 5. The next row contains average for department 1, and the remaining 3 rows contain average for department 4. Now this was a pretty long query. In order to simplify this query, here we have done one more thing in which we have calculated the average, but inside the over this time I have specified the group by in a way. So this partition by is similar to group by as I had mentioned. So what it will do is it will treat the department number and it will group the data with each department and calculate a department specific average. and map each average back to your original table. So here one we calculate the average salary, and next we calculate the total salary as well. The total salary we are aggregating based on gender. So here you can see I am specifying two different partition by clauses, one for department number and second for the gender. And this you can see once I run this, the output will be the same. It's just that it will be much simpler. So here you can see the first I'll show you the department wise average. So let me just move this average column here. So if you see for department 1, the average is this. For department 4, the average is this. For department 5, the average is this. Exactly same result, much simpler. And same way for gender also, the second aggregation was to calculate the gender specific total sum. And you can see for females, the gender specific sums are same. For male, the gender specific sums are same. And so this is a much easier way to implement the same aggregations and you map it back to your original table as well. Now I already explained this syntax. In this syntax, we write the window function first. Then we write the over clause. Between the over clause, we write the partition by and which column we want to partition the data on. I have not yet discussed the order clause and the frame clause. Those are the coming topics that we will cover. But till now, I have explained inside the over clause what's the use for the partition by clause. Using partition by, you specify the groupings of your total data set. So here, the sequence of code for window functions is defined as follows. So when you write any window function expression, so here we are talking about specific expression. You start off with an aggregation function. This aggregation function could be like a sum, count, average, right? Plus the column you'd like to track. So in this, inside the sum, which column do you want to calculate the sum of? So let's say, let me give that example also. Let me give an example for count because since we haven't mentioned over here. So now let's say I want to count total employees in each department and I want to map that column to my employee table as well. So what can I do? Let me write that down. Count number of employees in each department. So for that, simply I'll do select. Let me do a department number or SSN ID. I'll do department number and I'll also select, let me select just these two for now. And next I want to select count star. And here next I'll specify the over clause. Here I want to define a partition by department number as employees or total employees. And this will do from employee table. Now this will do what? Here you can, instead of specifying star, you can specify SSN also. It will just count the non-null SSN IDs in each aggregation. So if I run this, so here you can see in department 1 we only have one employee. In department 4 you can see we have these 3 employees. So therefore the count here is equal to 3. In department 5 here we have 4 employees. These 4 employees are part of department 5. So therefore the count is 4. So you can use this aggregation function to specify which column you want to aggregate by. Then comes the over. After over, within the parenthesis, you will specify the criteria for partition. Now within each department, if you want to count number of male and number of female employees, then all you need to do is specify 2 columns for aggregation. So this will do in each department how many male employees are there and how many female employees are there. Right. So if I run this query now, so here let me select the gender as well. That we are just seeing that in output. So here you can see for department 1, there is one male employee, therefore the count is 1. In department 4, we have 2 female employees, therefore the count here is 2. And in department 4, we have one male employee, therefore the count is 1. Now coming to department 5, we have one female employee, therefore count is 1. And in department 5, we have 3 male employees, therefore the count is 3. Right? So this is basically how you define aggregations, and you can even aggregate using multiple columns in a single query. So here is a quick comparison between group by versus a window function. So this is just to recover or recollect what we have discussed so far. So when you run a group by statement, the number of rows in the output are limited by the number of unique categories that you have in your aggregation column. So if the department has 8 categories, then you will only have 8 rows in the output. But in case of partition by, the number of rows in the output are equal to your input rows. Right? And the output is 1 row per group in the result set in the group by statement, meaning so for each unique value, you will have 1 row in the result set. Whereas in case of partition by, for each value of the department, you can have multiple rows depending upon how many rows are there for the department. And then there are similarities as well. So when you talk about similarities, these both do a grouping based on the column that you have specified and return your result based on the rows in each specific grouping. Right? So they both, in a way, are helping you to synthesize information over time. So the similarities basically is that both group by and aggregations allow you to create new columns by aggregating original columns using some categorical column in your data. The difference is, again repeating myself, in aggregation using group by, we basically are limited to the number of unique categories in the categorical column. Whereas in case of window functions, the number of rows in the output are equal to the number of rows in the input. Now there are a couple of key notes that you have to keep in mind whenever you are using window functions. These are very important points. So please remember that you cannot use window functions and standard aggregations in the same query. That means that if you want to just aggregate sum of average or sum of salary, and also you want to calculate sum of salary and you want to map it for all the rows, that does not make sense. So you can either calculate a standard aggregation in which you will get a point estimate, or you can run an aggregation in which that point estimate is mapped to each and every row. Meaning you can either run a standalone query without aggregations, without window function, or you can run it with window function. You cannot do both simultaneously. And similarly here, you cannot use a window function and a group by clause together. Those two are also not allowed. So in a query, you can either use a group by or you can use a window function. And second is, I've already explained or given example of this one. The second one is to use as many window functions as we want in a single query. So in the example which I had shown, in the same query, the first window function calculated average, but the second window function calculated sum. And both the window functions were doing different aggregations. So the average aggregation was done on the department column, and the sum aggregation was done on the gender column. Right? So both the aggregations were different, and they were window functions were also different. So both of them were different. So that that much room you have, which allows you to calculate each and every value independent of the other aggregations. Right? So now let's discuss aggregates in window function. So what are these ranking functions that we are discussing right now? So the ranking functions that we want to discuss allow you to associate rank to each and every row of your data. Let me explain that with an example directly, because it's much easier to understand these with the direct examples. All right. So here I'll simply do a select statement in which I want to select my employee ID and the salary for each employee. And this time I want to assign, let's assign them a rank. And I'm not specifying anything inside over for now. Right. So I'm just leaving over as it is, as salary rank. And this I'll do a selection from my employee table. So here I'm using the rank function, which is used to assign rank to each row. The way it works, I'll explain that in a second. Then inside over, again, it's used to specify the partitions that we are creating. Currently, we are not creating any partition, so it will consider all the rows as a single block of data. And we are just assigning it an alias. So on running this, you will see that right now, all the values are, sorry, here we have to specify which column you want to calculate the right. So without anything, it will basically assign each value a rank of 1 because we have not specified on which column we want to calculate the rank. Right. So right now, if you see the output as of now, you will see that the output as of now does not contain any column which can be used to calculate rank. So here you have to be specific about which column you want to use to in order to calculate the rank. So right now we are not specifying any column here, so it will just give a rank of 1 to each row because we have not given anything. But here if you want to calculate rank based on salary, so in that case here you have to specify the order by salary statement. So what it will do is that it will sort the rows in the increasing order of salary and assign a rank that's based on the order of the salary. So here if you now see the ranks are changing. The first 3 rows have the same salary. You can see the first 3 rows have same salary, so therefore they get a rank of 1. The next row has the next highest salary and the rank here is equal to 4. Now why is this getting equal to 4? I'll explain that now. The way this 4 is getting calculated is that because the previous rank was 1 and there were 3 rows with rank of 1. So here you can see there are 3 rows in which you have a rank of 1. So therefore the next available rank will be the previous rank plus the number of values in that rank. So here the previous rank was 1 and the number of values in the previous rank were 3. So the next available rank will be 1 plus 3, which is 4. All the intermediate ranks will not be there. Then you can see here 30,000 there is only one row, so one row will get a rank of 4. The next highest salary is 38,000, it gets a rank of 5. Why it is getting a rank of 5? Because the previous rank was 1 and there is only one row for that rank. So the next available rank becomes 5. The next highest value is 40,000, which gets a rank of 6. Again the same logic, previous available rank was 5. 5 plus 1 is 6. Next highest value is 43,000, it gets a rank of 7, which is 6 plus 1. The next highest value is 55,000, which gets a rank of 8, which is 7 plus 1. So by using a rank, you can calculate rank of salaries of each employee in your table, right? So you can just calculate a rank. So based on a column, you can assign ranks to, let's say you have some student database. In that student database, you have calculated percentage marks scored by those students. Now you want to calculate rank of those students in that class. Obviously, student which gets the highest score needs to get a rank of 1 and student with the lowest score needs to get the lowest rank. So all you need to do is basically call this window function of rank and you can specify that, do the sorting in the order of the marks. So instead of salary, you have to specify marks. But one difference that will be there is that here the order of sorting will be descending. Just same here, right? So here marks, you would be sorting in the descending order. Here also I can sort the salary in the descending order. So what it will do, it will first sort the values in the descending order and then assign the ranks. So 55,000 is the highest value, that's why it gets a rank of 1. 43,000 is the next highest value, it gets a rank of 2. Then 40,000, 3, 38,000, 4, 30,000, 5, and then 25,000. Here there are 3 rows, therefore all 3 get a rank of 6. So by using the rank column, you can calculate rank across all the rows of your data depending upon which column you have specified. All right. So here what we were doing is we were not partitioning the data by any means. We were considering all the rows as part of one single data block. Now in this only you can even specify a partition clause. So here next rank which I'll calculate, let me calculate another rank. But this time the rank which I'll calculate will be based on the gender as well. So here I'll do a partition by sex, order by salary in descending order. That is for each gender I want to calculate the highest to lowest ranks in the salary. All right. So here let me call it as sex, salary, rank. So now here you will find that we have two different options and I'll also select the gender column here because we are just doing a partitioning by that column. So now here if you take a look at the first column, so let me move this column here. So here just look at the salary column for now. And in the salary column, if you see, we have sorted first the salary in the descending order. So in the descending order, you will see that the highest salary is 55,000, therefore it gets a rank of 1. The next highest salary is 43,000. It gets a rank of 2, 43,000, rank of 3, and so on. Now let's move on to the gender column. So if you take a look at gender column now and just sort the values in the gender column, what you will find is that in the gender column for female, just focus on the female value. So the highest salary in female is 43,000. Therefore, it gets a rank of 1 in the female category. The next two highest values are 25,000. So therefore, both of them get a rank of 2. Now moving on to the male. In male, you have values starting from 55,000. This is the highest value. Therefore, it gets a rank of 1. Right. So here, if you see, focus on this value now. So 55,000 gets a rank of 1. 42,000 gets a rank of 2. 38,000 gets a rank of 3. 33,000 gets a rank of 4. And 25,000 gets a rank of 1. So here, even you can specify your partitions within the rank column. So basically, let's say you have data for all class 10 students. And these 10 students are divided across 4 sections: section A, section B, section C, and section D. And you want to calculate ranks specific to each section. So what you will do, you will basically specify a partition based on the section and do an order based on the marks. This will output for each section which students have scored the highest marks in that section and the lowest marks in that section based on the rank. So the partition will allow you to segregate the data based on the category, and then you can specify the rank based on the numerical column which you have specified. Right? So that is one of the ranking columns that we have. Apart from the rank column, we also have another column called dense rank. So there are two varieties of rank. You can either calculate a regular rank, or you can also calculate something called as a dense rank. So let me give an example of dense rank now. So let me remove the second query for now, just to explain what dense rank does. If I run the dense rank now, what you will find is that in dense rank, one of the main changes which comes is that the next rank is equal to previous rank plus 1, irrespective of how many employees are there in the previous rank. So you can see the first rank which was given to 25,000, it was 1. Here I'm sorting it in the ascending order of salary, right? So I'm sorting the rows in the ascending order of salary and assigning it a rank. So in dense rank, the next available rank will be previous rank plus 1, always. It doesn't matter how many rows are there in the previous rank. The next available rank is 2, then 3, then 4, then 5, and so on. So that's the only difference between rank and dense rank. The rest of the theory remains the same. Right? So if you want your ranking system to be behaving like dense rank, that is the next rank should be always equal to previous rank plus 1, use the dense rank function. But if you want your next rank to be equal to previous rank plus the number of entries in the previous rank, then use the normal rank function. And here also you can specify the partitions like always. So here you can do a partition by sex and order by salary. So what it will do is that it will calculate for each gender first. So you can see for female, the shortest value was 25,000, it gets a rank of 1. Then the next highest value is 43,000, it gets a rank of 2. It doesn't matter how many values are there in the previous rank. Then for male, we have one value each for each salary. So we have ranks 1, 2, 3, 4, 5. So same as rank 1. So that's the next function. You have rank and you have dense rank. The last very useful function that we will cover today is called row number. Now this row number function comes in handy whenever you want to assign a row number for each row of your data. So let's say salary and sex, and this time I want to calculate my row number here, and I'll just write the overstatement as number. Oh, sorry, I did not put a comma here. Right. So if I execute this now, so here you will see it will simply assign a row number against each row of your data. So here you can see first row gets a row number 1, second row gets a row number 2, and right now there is no order in which the data is sorted. Whatever order the data is available in the main table, it has assigned a row number in that order. So first row gets a row number 1, second row gets a row number 2, third row gets a row number 3, and so on. In between, you can even specify partitions. So let's say you want to partition by gender. So it will calculate row numbers for each gender now. So you can see for females row number 1, 2, 3, for males row number 1, 2, 3, 4, 5. All right. So it will partition by the gender and then calculate the row number for each gender. Right. Within this, you can also do a sorting. Let's say you want to assign the row number, but you want to sort them in the salary. So what it will do, it will sort the results based on the salary and then calculate the row number. So here you can see the values are sorted in the ascending order and the row numbers are calculated 1, 2, 3. Here the salaries are also sorted in the ascending order and then the row numbers are calculated 1, 2, 3, 4, 5. Now don't say that this is working similar to your dense rank, because in dense rank, both these two rows would have gotten the rank of 1. Right? Because both the values are same. But in this case, we are just assigning a row number. So the first row will get a row number 1, second row will get a row number 2, third row will get a row number 3. Right? So that trend will continue. It doesn't matter if the values are repeated or not. So these are the common, you can say, which is just a basic introduction to what window functions can do and how you can use ranking and aggregations in combination with these window functions. And inside the over clause, I have currently explained to the use of partition by and order by. Using order by, you can sort the data and it will allow you to calculate the ranks based on the sorted order. And partition by will allow you to partition the data based on the column that you have assigned here.